This is not needed. Already charged. Hmm?
11 o'clock NCERT class available.
NCERT class?
NCERT. அந்த வீடியோஸில் படிச்சு முடிச்சே இல்லையா அந்த வீடியோஸ் முடிஞ்சு
ठीक है रहेगा. मेरे पास जनरल भी नहीं भेजना.
बैटरी है
बैटरी तो पूरा है.
पासवर्ड आ जाना
हाँ हाँ. ठीक है सर. वो फिर वो आप लिंक दे देना इसका. मेरे पास पता नहीं लिंक क्यों नहीं दिखा रहा. मैंने ऐसा मैंने पहले से भेजा ना. नहीं दिखा रहा. अभी चलो. अच्छा यहाँ पे उसका सिग्नल नहीं आ रहा। यहाँ पे मेरे में स्काईलिंक कनेक्टेड था, मैं सोच रहा जूम लॉगिन करने के लिए।
क्या तो नहीं चल रहा, नेट ही नहीं है,
हैं?
नेट नहीं है।
हाँ, इसमें इससे कनेक्ट करता हूँ।
2 लिखे क्या नहीं,
हाँ।
2490। इसका ये ऊपर वाले जो पार्ट है ना वो कहीं ना हो
लाइट वाला।
Recording in progress.
All right, student, can you hear me clearly, all of you? Guys, can you hear me?
मैसेज भेज रहा है।
Okay, guys, another thing, like better always ask your doubt over Zoom, like say it out loud. All right, because message I might miss it out. You can also send in the chat, but still preferably say it out loud. Okay, so guys, we were looking into functional equation earlier. All right, now in the functional equation, in fact, I've given you a big assignment of 100 questions. So any one of you try it out, got anything? Raghav, did you got anything? Raghav is not there. Okay, looks like Raghav enjoying. Okay, then I'll ask someone else. Subiksha, did you try out the worksheet of functional equations? Okay, fine guys. So what we'll be doing today is, today we'll be looking into ITF. Now functions we are done. There is nothing more in function. Finish the worksheet. I'll write down for functional equation each and every answer. I'll send it to you, but you have to do each and every question if you want to do really good in JEE. Vishwant, how much you have done? What is not clear?
Basic substitution we need to do to find
Okay.
proceed further.
That is the only important part, right? That is not clear. Okay, so guys, we'll look into ITF, inverse trigonometric function. So we'll look into ITF, inverse trigonometric function. So the name itself suggests what we have. We have inverse trigonometric function. Now, when we talk about inverse trigonometric function, what is the first word in the name? Inverse. Now, is every function invertible? Which function are invertible, Kaushal? Onto. But what we are talking about, we want to talk about inverse trigonometric function. Now tell me which trigonometric function is 1 to 1? All of them are 1 to 1. You're also making me lose confidence 1 to 1. No, no. Ramaditya, can you tell me which of the trigonometric function is 1 to 1? Yes, tell me.
Sir,
All functions are 1 to 1. Okay. Gautam, tell me which all trigonometric function are 1 to 1? Gautam, which all trigonometric function are 1 to 1? Right. Gautam, mic is not connected. Okay. Okay, I'll ask someone else. Bhavin, you tell me which all function are 1 to 1 in trigonometric functions? Guys, we are studying ITF. The name itself. You are making a mistake in the name itself. Bhavin, tell us which trigonometric function are 1 to 1. Bhavin, we are waiting for you. Tell us quick so that we can move ahead. Bhavin is also quiet. Or I don't know whether his YouTube is learning very behind. Gautam is on mute. Okay, Raghav is there. Now finally Raghav has joined the meeting. So we'll also ask Raghav. Now Raghav, tell us which trigonometric functions are 1 to 1. What? Gautam?
sir, the domain is
Okay. Guys, I'll tell you what we'll do. Now, not a single function, trigonometric function is 1 to 1. Why it is not 1 to 1? Because all of them are periodic. Every periodic function repeats. And if a function repeats, it cannot be 1 to 1. Let's draw the graph of sin x. Now, this is the graph of sin x. Sin x graph will repeat. It will repeat. We have talked about this, that if we draw any line parallel to the x-axis should cut the graph at most once. Only then it's 1 to 1. But look at this. If I talk about this point, like pi minus x, all these points will give us the same value. This point, pi minus x, or this point 2 pi plus x, all the different values of x will give us same value of y. So not a single trigonometric function is 1 to 1. Now the question arises, if trigonometric function is not 1 to 1, then how come we'll study inverse trigonometric function? So Rishwant, any guess? Or this whoever decided the curriculum is making fool out of us. First they are telling us inverse function should be 1 to 1. Now they are teaching, like now they're asking us to study inverse trigonometric function. Okay. So guys, correct. Now all of you are answering good and all of you are answering correct. Good. So that is what will happen over here. All of you are correct. We will cut down. We will clip. All of you know the meaning of clip, right? Clipping, cutting. So we will cut down the graph. Right now the graph is not 1 to 1. The sin s graph. So if I draw the complete sin s graph, this is the graph of sin x will look like. Like not complete. No one can draw complete graph because it goes to infinity. All right. Even if I try to draw for one more year, still I cannot draw it. This is sin x. Now it is not 1 to 1. So we will take that part of sin x where it is 1 to 1 and covering every part in the range. Now range of sin x is minus 1 to 1. Correct. So we will cut in one part where it is going from minus 1 to 1. So we will cut either over here in this part. Okay. Or we can cut in the other part also. Other part means we can cut it over here. So let's call it as this one as the first part and this one as the second part. Now if you look only in the first part it is 1 to 1. and also only in the second part also it is 1 to 1. Right? Here it is strictly increasing. In the first part it is strictly increasing. Second part is strictly decreasing. That's how we find it out. To find a 1 to 1 function, we were taking derivative and then we were checking increasing or decreasing. Now that we have got this first, second part, now which one shall we cut? First part, second part, or any other part? Raghav, which one shall we cut? First part, second part, or any other part? No, that is fine. But in this first part from here to here, or second part here to here, or third part here to there, which one? Now, okay. No, but within that part it won't repeat, right? My point is, in single part it should not repeat. Okay, I'll tell you guys. We can cut anywhere. It doesn't really matter. We can either cut from minus pi by 2 to pi by 2, or pi by 2 to 3 pi by 2, or 3 pi by 2, 5 pi by 2. Anywhere we can cut. Anywhere we can cut, it is not going to matter. It is not going to matter because in that part it's going to be 1 to 1. So if we are cutting like the first way, so what will happen? The graph will look like this. This will be the graph of sin. If we cut in the second way, then the graph of sin x will be like this. Now this is from pi by 2 to 3 pi by 2. And the previous one, this is from minus pi by 2 to pi by 2. So we could have cut in any way. It doesn't really matter how we cut this graph. So two things. First, we have to cut it to make it 1 to 1 and onto, because only 1 to 1 onto function can have inverse. Second thing, we can cut it in anywhere it is 1 to 1 onto. But it's a general convention. It's a general convention that we try to cut near origin. Why we try to cut near origin? Because inverse. What is inverse function? It is nothing but mirror image on the line y equal to x. So if you are cutting very far away, image will be very far away. If there is no advantage of cutting far away, then why to even do that? Drawing will become a headache, right? So that is why we never cut the graph at far away points. We cut it near the origin. We cut it near the origin. So sin x we cut from minus pi by 2 to pi by 2 to make it 1 to 1. Only then we can find out inverse. So we'll come back to inverse trigonometric function. So because all trigonometric function are periodic, that means many to one. So we have to cut all of them. So now we have to see how to cut them. So when we talk about sin x or tan x or cosecant x, these three we cut from minus pi by 2 to pi by 2. For some of them, like for tan, minus pi by 2 to pi by 2, like those 2 points won't be defined. So for tan it will be open bracket, sin it will be close bracket. For cosecant 0 is not defined, so 0 will be open bracket. That is the only difference. But this is the interval in which we'll be cutting. As for the others, that is cos x, secant x, and cot x. For these three, we will be cutting from 0 to pi. Because you will see that cos is not 1 to 1 between minus pi by 2 to pi by 2. Cos is many to 1. Cos will be 1 to 1 between 0 to pi. So this will be the intervals. This will be the intervals in which we will be cutting. Any one of you have any question, any doubt till this point? Okay. So now we will be drawing it. We will draw it. We'll see how we are cutting all of the graphs. Then we'll look into the inverse. And then we'll approach to domain range and we'll see different graphs and so on. So first we have to understand the basic part. How to cut, how to clip it to make it bijective. All right, so now we will start cutting the graphs. So what we will do over here is, first of all, we'll look for the sin x. We'll look for sin x. Now, sin x, if we talk about sin x, we will be cutting from minus pi by 2 to pi by 2. This will be the complete graph, something like this, but this is the part in which we'll be cutting it. Similarly, next we will see how to cut cos x. Now this is the graph of cos x. Like the dotted lines is the complete graph, and the whatever we have drawn is the part in which we are cutting it. So after cutting the graph, this is the only part left to us. Now this, after cutting the graph, what we get is a restricted domain. So now what will be the domain of this new sin x graph, Rishwant? What is the domain? Correct. So domain we will get over here from minus pi by 2 to pi by 2. This will be the domain. Similarly, if you talk about sin x, so for this sin x, what will be the range? It will be minus 1 to. So we will get now sin x from minus pi by 2 to pi by 2 with a range minus 1 to 1. With a range minus 1 to 1. So now when we are taking the inverse, we have to interchange the, or domain and range, or we can say we have to take mirror image about y equal to x. So we will see how to draw y equal to x. Now this line, this black colored line will be roughly y equal to x. This is the line y equal to x. So if you take the mirror image will look something like this. The mirror image will look something like this. So from here we arrive to important conclusion and we say sin inverse x graph. It will be like this. And this will be the line y equal to x. This is the line y equal to x, and this will be the graph of sin inverse x. This will be graph of sin inverse x. We are just taking mirror image on the line y equal to x. Now, after we have done this, we have to write down domain and range of sin inverse x. So from here, we can say that if we are talking about sin inverse x, the domain of sin inverse x will come out to be as, now whatever was range now will become domain. So in fact, if you want to plot this point will come out to be 0, 0, pretty obvious. If we talk about this point, what will be this point, Rishwal? Initially, what was this point? Comma 1. Now it will be what point? This point will be 1, pi by 2. And similarly, this point will be minus 1, minus pi by 2. So its domain will become minus 1 to 1, and range will become minus pi by 2 to pi by 2. Become minus pi by 2 to pi by 2. Also remember this, that sin inverse x is a strictly increasing function. Sine inverse x is a strictly increasing function. All right. Nivedita, are you clear on this part? All right. So this is about sine inverse. Now a similar way we look for cos inverse. So cos inverse we have clipped from 0 to pi. So if we talk about domain right now, after clipping it between 0 to pi, like this point will be 0 comma 1, and if you talk about this point will be pi comma minus 1. So we have clipped it over here. Now this will be the line y equal to x. We have to draw the line y equal to x. So this line will be y equal to x. Y equal to x. So if we take its mirror image, the mirror image will look something like this. The mirror image will look something like this. So if you talk about the graph for cos inverse x, the graph of, guys, graphs are very important. In function, we have not seen inverse trigonometric function because we didn't know what is inverse, what is 1 to 1 and so on. Now that we know, graphs of ITF are going to be important. You need to have or remember that on your fingertips. How the graph will be on your fingertips? You will touch the graph with the fingers. Rishwant, how will you make the graph on your fingertips? By drawing so much that you remember it, not by touching the graph with your fingertips. So if you talk about the graph of cos inverse x graph will look like this. Cos inverse x graph will look like this, and we can easily find out domain and range as well. So if we talk about the domain again will be minus 1 to 1 just as sine inverse. But when we talk about the range will be 0 to pi. This is how we will get for cos inverse. This is how we will get for cos inverse. Now we'll look for the other, that is, we will look for tan inverse and cot inverse. All of you note this down. In the meantime, I'll rub out the other part. What? Which 0? No, it's in closed bracket. It's included. If the function is defined over there, inverse will also be defined over there. Okay. Now we have to look for tan and cot. So U1 tan is clipped in which part? Which interval? Tan x is clipped in which interval? Correct. So tan x is clipped from minus pi by 2 to plus pi by 2. Now this will be the graph of tan x. This will be the graph of tan x between minus pi by 2 to pi by 2. It will repeat, but we are not drawing that for the time. Now, unlike sine, remember that tan will be in open bracket. In sine, minus pi by 2 and pi by 2 was in closed bracket. But Raghav, can you tell me why for tan it will be in open bracket? Correct, absolutely correct. Because it is not defined. So we cannot include it. Now, okay, now that's a very nice question. Now, in the first quadrant, Haneet, you have to answer this. So the question is, in the first quadrant, tan x graph will be above the line y equal to x or below the line y equal to x or intersecting. That means both above and below. Okay. I don't know whether Hani's video is lagging a lot or Haneed is lagging a lot. Okay, then I'll ask someone else this question. So let's say there are three cases. My point is whether the line y equal to x, whether the line y equal to x will be like this. Yeah, tell me. First it will be below, then above the line, above tan x. Like what I've drawn is one of the options. Do not think this is the original line. I was asking like this, or like this. So option 1, 2, or 3. How it will be? Option 1 or option 2 or option 3? Haneet? Okay. Okay, why it will be always below tan x? Okay, guys, it's very simple. You can just take the derivative of both of them. Correct. You are absolutely correct. Okay, so that is what will happen over here. So we can say that the line will be always below tan x in the first quadrant. And using the same logic, we can say in the third quadrant it will be above tan x. So this is what we will get. The other two are wrong. So we have to rub out this part. All right. Guys, you should be very clear in this, like in above or below. It makes a lot of difference. What is above, what is below. Already one? Big difference. What is above, below. All right. So this is what we'll get. So now if we draw its mirror image, if you draw its mirror image, the mirror image will be like this. So if the function is always above the y equal to x, so mirror image will be always below y equal to x. So it will be like this. Okay, I'll draw it separately so that you do not get confused. So the graph of tan inverse x will look like this. This will be the graph of tan inverse x. Now its domain and range, if we talk about it, so we'll get domain will be all real number r, and if we talk about the range, it will be open bracket from minus pi by 2 to pi by 2. This is what we'll get. Now guys, whenever we are making a mirror image on the line y equal to x, one very important part that you should remember is about the asymptotes. Now, if we talk about asymptote of tan x, so tan x asymptotes are these two. These are tan x asymptote. So asymptote for tan x. Asymptote for tan x was x equal to pi by 2. X equal to pi by 2. Now think about this. When you are taking mirror image on y equal to x, let's say this is a line. If I take mirror image about y equal to x, so this line up after taking the mirror image will be this one. Why? Because it will be equally inclined to mirror. So 45 degree, now 45 degree. So if initially asymptote was x equal to pi by 2 for tan x, so for tan inverse x, these two will be asymptotes. So we'll say asymptotes. Asymptotes will be y equal to plus or minus pi by 2. So that is why pi by 2 will never be the part of domain. Sorry, range. It will be part of domain but not part of the range. So this is what we will get over here. All right, guys. In the meantime, all of you think how you will draw for the remaining three: cot inverse, secant inverse, and cosecant inverse. I will give you exactly 3 minutes, and you have to send me this on WhatsApp for those who are of you who are attending online. Draw the graph. Like graph means do not copy from some book or internet. You draw the graph of secant, cut it, then secant inverse by taking mirror image, and I want to see all of that. Send me on WhatsApp. यही तीन कलर चाहिए बस, यही तीन कलर ठीक रहता है.
चला रहे
हाँ, चल रहा है, चल रहा है. Harish Aditya, Bhavin, send me your graphs quickly. I want to see that on WhatsApp. Okay. By the way, one more thing, guys. I have two WhatsApp numbers. So send me the one which ends with 56 at the end, last two digit. Do not send me on the other one, because in the other one, the class is being live streamed, so I cannot check it. Okay, or Neon, you can send in both of them. I can check through laptop. Send me the graphs, guys. Draw the graph for all the inverse functions. Draw function and inverse together. Also check whether y equal to x will have some intersection with the curve or not. For example, y equal to x had an intersection with cos, but not with sine and tan. Similarly, check whether there will be intersections or not. You have to be very clear in the graph domain range for inverse functions. Okay. Till now, I have not received a single graph. Guys, send me your graphs. Be quick. All right, I've got few graphs. Now, Raghav, in secant x, we are going to cut it from 0 to pi. 0 to pi. So 0 to pi means like you cannot have both in first and third quadrant. For secant x. Wait a second. Bridu, you have drawn the graph of cosecant. Bhavin, your graph is correct. Good. Mokshita, yours is also correct, but try to draw secant parallelly with that. Pranesh, do not draw just the individual graph, like draw both inverse and the function. Otherwise, it might be highly possible that you are getting from here and there. Okay. Gautam, yours is correct for cosecant. I think you have drawn for cosecant and cosecant inverse. If that is the case, it is correct. Okay, so we will have a look over here. So first we will draw for secant because many of you have sent me secant. So we'll look for the graph of secant x. Now, see guys, always draw the original graph. That will help you to get clarity. Inverse you can draw. But the thing is, if you draw both together, analyze it. That's how you get the clarity. Okay, now what will happen over here in secant x? In secant x, now this will be the graph of secant x. Now this is the graph of secant x. Now we have to cut it. See, first of all, where to cut? Only thing in your mind should be to be 1 to 1. Okay. So Ramaditya, your graph is almost correct. It's just that on the left side of y-axis, it should not be that close. Like it's kind of correct. It's just that it looks very close. Okay. So this is what we have got. Now we have to clip it. We have to cut it down. So we have to cut it down in such a way that it becomes 1 to 1. So that will do in 0 to pi. Again, guys, I'm telling you, we could have cut it everywhere, anywhere else. We could have cut it anywhere else. But now why we are cutting in this part? Because it's near origin. Drawing it will be easy. See, if I have the origin over here, I'm drawing over here. What people will think about me? They'll think that I have what I have eaten or what I have drunk, right? I do not want people to think like that. That's why near origin makes sense. But apart from that, no reason. So now this will be the graph. Now we'll draw y equal to x. Now does the line y equal to x will have intersection with secant x? No, it won't have intersection with secant x. Correct. This will be the line y equal to x. Now remember, anything which is parallel to x-axis will become parallel to y-axis. Anything which was parallel to y-axis will become parallel to x-axis. Now this was asymptote. This was asymptote. Asymptote was x equal to pi by 2. Asymptote was x equal to pi by 2. Now what will be new asymptote? New asymptote have to be y equal to pi by 2. Because at this point x and y are same. And if I talk about the mirror image, it will be like this. So mirror image I'll draw with a different color. So for this asymptote, we'll get it to be like this. So this is what we'll get. So this will be my new asymptote, the blue one. So we'll separately draw it over here also. So this will be our new asymptote. That is y equal to pi by 2. So initially the asymptote was x equal to pi by 2. Now it will be y equal to pi by 2. Now we have got our asymptote. Now this is on this side of asymptote. Like mirror, asymptote, curve. Same thing again should happen. So we should get mirror. So mirror, then asymptote, then the curve. So the curve will be like this. So if I want to talk about this, these two are mirror image. These two are mirror image. These two are mirror image. Now if we talk about this point will come out to be as minus 1 comma pi. Now we'll look for the other part. Over here we have this mirror, asymptote, curve. Same thing will happen over here. We have mirror, asymptote, then the curve. So when we are drawing it on this one, it will look like this. And this point, if we talk about this point, can any one of you tell me what will be this point? It will be 1 comma 0. It will be 1 comma 0. So this will be the graph of secant inverse. Now if we talk about domain and range, domain will be R minus, in the open bracket, minus 1 to 1, and range will be 0 to pi, excluding pi by 2. So guys, like this, analyze about the mirror, analyze about the asymptotes, because if you do that, only then clarity will come. And once clarity will come, ITF will be the easiest chapter for you. In ITF, there are only two things. It's a very small chapter and easy: graphs and general solution. We'll see what is general solution later. We just have to find general solution, like what is general solution of sine cos. Same thing we apply in ITF. That's it. If you're good at these two things, you are perfect at ITF. So this is for secant and secant inverse. Next, we will look for tan and tan inverse. Okay, chord and chord inverse. So we'll draw the graph of cortex. So when we are drawing the graph of cortex graph will be how? Between 0 to pi. This will be the graph of cortex between 0 to pi. Now we have to take the mirror image. We have to take the mirror image about the line y equal to x. Now there are two asymptotes. This is one asymptote, x equal to 0, and another asymptote, x equal to pi. So now these two asymptotes will become y equal to 0 and y equal to pi for the inverse when we talk about the mirror image. So let's say we are talking about the mirror image. So this will be our asymptotes. That is, one is y equal to 0, other is y equal to pi. Now mirror, graph, asymptote. So it's going parallel to asymptote. So over here also parallel to asymptote. And same like this. It is not touching over here. Do not think it's touching. It's like going very close. So this will be the graph of cortex. Now if we talk about domain will be all real number R. But when we talk about range will be 0 to pi, both excluding. All right. Guys, let me know if any one of you is having any doubt or any question till here. Okay, by the way, if you want, you can also send in the chat. I think for some of you, if this is not working, I'll also open my chat parallelly so that I do not miss out in your questions. Okay. Now we have to draw for the last one. That is, we have to look for cosecant. I'm also repeating now. Okay, so we have to look for cosecant. All right. 1 second, guys. I'll be back in a minute. In the meantime, all of you try finishing the graphs and think about it also. इसमें ऐसा ना मैं हनी से पूछ रहा हूँ. All right. So we'll have a quick look at this one. So for the last one, that is our cosecant x. By the way, guys, I hope those of you who are attending online are drawing it properly. Although I cannot check, I can only hope. And I hope my hope is not wrong. Okay, so we'll look for the cosecant x. So first of all, the graph will be like this. Now we will clipping it. We have to cut down it from minus pi by 2 and same over here. So now that we have cut it down, we'll draw the line y equal to x. Now guys, can you tell me, will there be an intersection with y equal to x or not? Will this curve have any intersection with y equal to x or not? Guys, those of you who are attending online, just because you are attending online doesn't mean that you should not reply. Reply, I want to hear it from you. Yes, there will be an intersection. There will be an intersection. So if you draw it, it will be like this. It will come out to be like this. Now that we have drawn this, we'll draw its mirror image. Now, first of all, we have to check for the asymptote. Now, this y-axis itself is the asymptote. So now asymptote will be x-axis. So we have it like this. So now if we look at it, the graph will be in this form. This point over here will be 1 comma pi by 2, and this point over here will be minus 1 comma minus pi by 2. So this is what we will get as the graph.
Yes.
Yeah, tell me.
For the cosecant x graph, y equal to 0.
Cosecant x, yeah, for cosecant x, the asymptote is y equal to, no, x equal to 0. Y-axis is x equal to 0. Y-axis is x equal to 0. All right. Are all of you clear to this point? Anyone, any doubt? Okay, yes. We have to look for the domain and range as well. So we will look into that. What will be domain? What will be domain and range for this one? All right. So over here, what will happen? When we talk about the domain over here will be same as the previous one, that is R minus minus 1 to 1. And when we talk about the range will be minus pi by 2 to pi by 2, except the point or except the value 0. So this will be its domain and range. This will be its domain and range. All right. All of you clear till this part? Okay. All right. So this is what we get, and that's how the graph will come out to be like this. Now, based on all of this, we'll take some few simple questions. We'll take few simple questions. Now, all of you quickly answer all of that. So you have to find out. You have to find out domain as well as range. We'll take few questions based on simple domain and range. So you have to find out domain and range for the following one. That is, find out for sine inverse e power x, sine inverse fractional part of x, cos of greatest integer of x. Find out its domain and range. You have to find out its domain and range. Guys, let me know as soon as you are getting any answer. All right, try it out. It's simple domain and range. What we have done earlier is just that we are putting some inverse trigonometric function. For which one? First one we need to find out for sine inverse e power x. Now what will be domain? Yeah. So what will be that? Guys, let me know if you are getting any answer. I am waiting for your answer. Right or wrong? Tell whatever you are getting. Minus infinity to 0. Absolutely correct. Good. Correct. That is also correct. Good. We'll have a look over here. So the thing is, anything inside sine inverse, that is e power x, should lie from minus 1 to 1. Now, e power x cannot be even negative. In fact, we'll have very difficult questions on all of this once we move on to LCD. That is the next chapter. In LCD, we'll see how to multiply function with e power x, like change it, convert it. In JEE Advanced also, this kind of difficult question have come. But yeah, coming back over here, if you talk about e power x will be always greater than 0. And e power x is 0 at minus infinity. So effectively, we will, from over here, we will say that domain will be minus infinity to 0, because at 0 e power 0 will become 1. And because e power x is always positive. Now if we look for the graph of sine inverse x, this was the graph of sine inverse x. This is the graph of sine inverse x. Now if when x is positive, what are the y values, positive or negative? If x is positive, y values are also positive. That means if x goes from 0 to 1, y will go from 0 to pi by 2. Also remember guys, that all these, that is sine inverse, tan inverse and secant inverse, they are strictly increasing. These three, it will be very helpful. And the other three, cosecant inverse, cot inverse and cos inverse, are decreasing functions. We'll solve inequalities, there it will be important. So this is domain, so obviously range will be 0 to pi by 2. Range will be 0 to pi by 2. Let me know if you are getting any other answer for any other part.
Domain is always numbers, sir.
Domain, yes, absolutely correct. Good. And range?
Sir, 0 to pi by 2 open brackets.
Correct. Good. So we'll look for the second one. We have sine inverse fractional part of x. Now over here, what will happen? Because fractional part always lies from 0 to 1. We do not have to do anything. So we can directly say x will belongs to R. All real numbers. Everything. But what is the range of fractional part? 0 to 1. And between 0 to 1, what is sine inverse? 0 to pi by 2. So from here, this will be the domain. And when we, yeah, tell me. Mokshita, I cannot hear you clearly. Did you ask anything? All right, we'll have a look at the previous question also. In the previous question, because what happens with e power x? Okay, we'll explain both first and second question one more time. So in first question, what is happening is we are getting sine inverse e power x. Now e power x is always positive. Even if you take x as minus infinity, it's always positive. So this should go from minus 1 to 1, e power x. It should go from minus 1 to 1, but it will never even take negative values. So even for all the real numbers or all the negative numbers, this is positive. The only thing is it should not be greater than 1. It should be less than 1. How we ensure less than 1? It should be less than 0. So domain is minus infinity to 0. E power 0 is 1. And after that, e power minus infinity is 0. So it will take all the values in between. Now that we have got this, we will look for the range. Now e power x is because it's always positive. So sine inverse x. See, this means x is positive. This means y is positive. So we can say that when x is positive, y value is also positive. So that is why now in sine inverse x, this was x. Now your new x is e power x. E power x is always positive. So that is why the range will be also positive, that is 0 to pi by 2. Because sine inverse cannot take values more than pi by 2. Now, as for the second part, we have sine inverse fractional part of x. We'll get the same condition, that fractional part of x should lie from -1 to 1. But by default, no matter what value of x you take, fractional part will always lie from -1 to 1. Not even -1 to 1, 0 to 1, to be more precise. In fact, fractional part of x will lie from 0 to 1. Even 1 will not be included. So because this thing goes from 0 to pi by 0 to 1. Now 1 is excluded. So I get pi by 2 at 1. So that's why pi by 2 excluded. 0 to pi by 2 everything. Is this clear to all of you? Okay. So third one, in the meantime, if any one of you have got the answer, let me know. Okay. Yeah. Yes. So in the third one, what will happen is that when we talk about the domain, the third one, when we talk about the domain, because we are getting cos of, okay, wait a second, I think I gave you wrong question. It should be cos inverse. Cos of fractional, sorry, cos of greatest integer of x we have been doing for many days now. Like you should be able to do that. I've given you many homework on domain. So this should have been cos inverse greatest integer of x. So do for this one and let me know what value or what answer you are getting. -1 to 2, open bracket, correct. Okay, domain, over here when we are talking about domain, greatest integer should lie from -1 to 1, that is correct. But when x is 2, like for example, let's say x is 1.9, even that will satisfy because greatest integer of 1.9 is 1. So that is why what will happen, we will say greatest integer of x, this should take value from -1 to 1. So x, this will belongs from -1 to 2, open bracket. 2 open bracket means anything less than 2. 1.99, greatest integer will become 1. So this is the domain. Next, we will look for the range. Anyone, any answer? What will be the range? Cos inverse. What is the range of cos inverse? Minus? Gautam, can you repeat your answer? Okay, 0 to pi, all the values. Okay, I'll ask you guys. Tell me what all values greatest integer will take. -1, 0 and only 3 integers. So what should be range? Cos inverse 0, cos inverse 1, cos inverse -1. So range will have only 3 elements. Those 3 elements will be 0, pi by 2 and pi. There will be only 3 elements in the range. All right. So this is what we do. Now, moving on. Next thing we are going to see, like I'll tell you what roughly we'll do in ITF. We have seen this. We'll see converting one ITF to another. We'll see properties. Then we'll see general solution. That's it. Over. Small and easy chapter. So next thing we are going to see is how to convert one type of ITF. How to convert one type of ITF to another ITF. That means if I have been given sine inverse, how can I convert the sine inverse to cos inverse? Now, we have been talking about ITF function now almost for an hour. Now, Kaushal, can you tell me what does ITF give you? Give you, which is, we have said function is a black box. Some input, some output. So what is the output of the ITF? Inverse trigonometric functions. Input is a number. What is output? What is sine inverse 1? That is also a number. But what is the significance of that number? It's an angle. It's an angle. Like sine of an angle is a number. Sine inverse of a number is an angle. So effectively it's an angle. And that angle I can write in terms of sine inverse, cos inverse, any method. So over here, what do we do is that, let us say we have been given sine inverse x. And we have been asked that what will be it in terms of cos inverse. What it will be in terms of cos inverse. So what we do is that we draw a triangle and we use Pythagoras theorem. It's very simple. We'll draw this triangle. Now, if let's say this angle is theta, if this angle is theta, what we'll do is we will assume that, let's say sine inverse x is theta. So can I say that x will be sine theta? If sine inverse x, because we know it's going to be an angle ultimately. Ultimately, it's going to be an angle. And for that angle, we are getting x equal to sine theta. Now, if this angle is theta, sine theta is x. X I can write x by 1. What is sine theta? Opposite side by hypotenuse. So we can assume opposite side as x and hypotenuse as 1. So what will be the third side using Pythagoras theorem? Will be root over 1 minus x square. We are using Pythagoras theorem. The sum of the square of two sides should be equal to square of hypotenuse. So this is what we have got. Now, if that is the case, then what will be cos theta? Cos theta is adjacent by hypotenuse. So we'll get it as root over 1 minus x square by 1. So what will be theta? Theta will be cos inverse of root over 1 minus x square. And that is how we have converted. Theta was sine inverse x. Theta is also cos inverse this. So from here we can say that this question mark will be equal to root over 1 minus x square. So that is how we convert one ITF to another. We have to complete the triangle and then just simplify it. So does any one of you have any doubt, any question till this point? Yes. We can use this for any value of x. Now, none of you ask me any doubt or any question. I have a question for you guys. So now, Raghav, I have a question for you. Now, whatever we have done that, is it correct or there is some missing things over here?
Theta has the choice whether it can range or not.
Okay. See, actually, what will happen is that theta will always lie on the range because otherwise the question won't make sense. You cannot find out x. You will get some impossible x. So that is not the problem. The problem is that because we do not know when I use Pythagoras theorem, I take a square. A square will make negative number also positive. That is the problem over here. See, sine x can also be negative. Cos x can also be negative. But when we take the square, we are assuming everything is positive. So effectively what we have done, this is only true if all angles lie in first quadrant. Why all angle in first quadrant? Because in first quadrant all the trigonometric function are positive. So in first quadrant all sine, cos, tan, cot, secant, cosecant are positive. So that is why effectively we are assuming that none of them is negative. We are assuming none of them is negative. So that is why what we have done is only correct in first quadrant. So unless nothing is given in the question, you can blindly assume that it's first quadrant. If it is given, then you find out what will be in first quadrant, then appropriately change the value for the other quadrants. That we will see with properties of ITF later, that how you can change it. All right. Haresh Aditya, is this clear to you? If your mic is not working, you can also reply in the chat. All right, good. So now this is what we do. So what we can do is that, so let us say if we want to change, I'll just do one more. Let's say I want to write cos inverse x in terms of cot inverse. I'll just do one more, remaining I'll give you questions. So what we will do, again we'll take up a triangle. I'll take this angle as theta. So we will say that let us assume cos inverse x is theta. So x will be cos theta. Now we can write x as x by 1. So this will be x, this will be 1. Third side will be 1 minus x square using Pythagoras theorem. Now that we have got this, we can also say what will be cot theta. Cot theta will be adjacent by height or opposite. So theta will be cot inverse x by root over 1 minus x square. So we can write it as this. We can express it in this form. express it in this form. All of you are clear? All right, so we'll take our quick questions. I'll write down the questions over here. All of you try it out. Find out the first one. All of you find out this value. Find out cos of sine inverse of cot of tan inverse x. Find out this value. By the way, guys, I'll give you a hint. Always remember, they are inverse of each other. So I can say that tan inverse tan x should be x. Like, this is not correct. Just now we'll see it is not always correct. But for the timing, you can assume it to be like this. Or tan of tan inverse x. This will be also x. It is correct for few part that we'll see later. But now, for now, you can assume it to be like this.
In terms of x.
Yes, you need to get the answer in terms of x. So convert into one form to another appropriately. Let me know if any one of you is getting any answer. Do not.
Root over 1 minus 1 by x square.
Okay, that sounds correct, kind of, Gautam, but I'm not sure. So we will have a look at it. So first of all, we have tan inverse x. Now, if let's say this angle is theta, so we have tan theta as x. So what will happen? We will get theta equal to
X square plus 1 by x square plus 2.
x square plus 1. Okay, I'm not sure about it. We'll check it once. We'll check it once.
Root over x square minus 1 by
Okay, now all of you are getting different answer. Now, more than checking, I'm getting scared. All right, you should use Pythagoras theorem properly. Let's have a look at it. So this will be x, this is 1. So this has to be 1 plus x square. So what we'll do, we can rewrite it as cos of sine inverse cot of cot inverse 1 by x. Now cot of cot inverse 1 by x, I can just write this entire thing as 1 by x. Their inverse function, they'll cancel out each other. So we'll get cos of sine inverse 1 by x. So now we'll draw another triangle. Now this triangle is our new triangle, not the old triangle, because now functions have changed. So for new triangle, this angle is theta. So we have sine theta is 1 by x. So this will be 1, this will be x. So this have to be root over x square minus 1. So now we have to convert to cos inverse. So this will come out to be as cos of cos inverse root over x square minus 1 by x. Now we can take out these two. So our final answer, we get x square minus 1 by x. So this will be the final answer. Are all of you clear on this? That is what you have done. Sine inverse 1 by x is theta. So what will be sine theta? 1 by x. Okay, we are just writing sine inverse in terms of cos inverse. We are saying directly I'll write the answer. How will you solve from here to here? Only cos and cos inverse will cancel out, right? Sine cos will not cancel out with sine inverse. Sine inverse 1 by x is theta. We have to find out cos theta, correct? Oh yeah, that is correct. That is correct. Okay, I'll give you guys 2 more questions. All of you find it out quick. Find out this one first. And once you are done, then find out for next one. Let me know if in case you get any answer. I'll repeat the previous question one more time. What we are doing is that we had cot of tan inverse x inside. So first we converted tan. Okay. I have to check your answer once, but that sound kind of correct. Okay, try out the other one as well. In the meantime, I'll just explain this one. We have cot of tan inverse x. Tan inverse x means if you take theta, so tan theta will be x. So x by 1, height by base. Third side we are finding using Pythagoras theorem. Then, once we have done this, we are replacing it with cot inverse. So cot and cot inverse cancel out, we get cos of sine inverse 1 by x. Now a new triangle. Again theta, sine x is 1 by x. So 1 by x. So third side using Pythagoras theorem. Yes. Alright guys, I'll give you a few more seconds, then we'll see what to do over here.
The first one I'm getting 1 by root of x square plus 1.
Alright. I think that's kind of correct. We'll have a quick look. All right. So in the first one, we'll look for the first one. We have sine of secant inverse. So first we need to convert. Inner function, this is cot. Okay, so coming to the previous one, we have sine in secant inverse that we have to convert to sine inverse. So secant inverse x means if this angle is theta. Yes, so sometimes it might be possible that it is impossible. All right, so you might get impossible cases as well. So we have to check for it. So in the first one, we get secant theta will be equal to x. So we can say this will be like secant is hypotenuse by this base. X and 1, so this will be root over x square minus 1. So we can write it as tan of cos inverse of sine inverse. Now this will come out to be as root over x square minus 1 by x. Now this will go away. So we are getting tan of cos inverse root over x square minus 1 by x. Now again we will complete the triangle. We'll make a new triangle. If this angle is theta, then we are saying what is cos theta? Cos theta is, this is x square minus 1. This is x. So third side, by default using Pythagoras theorem, will be root over x square minus x square minus 1, which will be equal to 1. So we'll get it as tan of tan inverse. We'll get 1 by root over x square minus 1. Now we can just cancel out tan and tan inverse. Tan and tan inverse just will vanish out. So if tan and tan inverse vanish out, then we'll just get it as exactly. Okay, we'll have a look at the second one. Okay, by the way, guys, I'll send you one more worksheet on functions today. That and functional equation, you guys try to finish it ASAP. All right. And based on that, we'll take up a doubt class again because we have to discuss the entire function. So we'll look for the next one. Next one, we are having cot of secant inverse of sine of cot inverse x. Now, first of all, we have cot inverse that we need to convert to sine inverse. So if you have cot inverse x, so if this angle is theta, we will get cot theta is x. So cot theta is nothing but this will be x, this will be 1. Third side will be root over 1 plus x square. So we can write it as cot of secant inverse of sine inverse. Sine theta will come out to be opposite by hypotenuse. Now these two will go away. So we'll get cot of secant inverse 1 by this. Now we have to convert it again in terms of cot. This is our new triangle. So for this triangle, now secant is nothing but hypotenuse by adjacent. So this will be 1, this will be root over 1 plus x square. So what will be the third side? If you use Pythagoras theorem, using Pythagoras theorem, what will happen? We'll get 1 minus x square, which is equal to root of minus x square. So it's a complex number. It's a complex number. It will be equal to xi. A square minus b square. So we get minus xi. Sorry, xi. What is xi? Like it's a complex number, right? So we are getting inverse of a complex. Now these kind of function are known as hyperbolic functions. All right, but that is not part of the syllabus, so we'll skip it. So we do not have to worry for hyperbolic functions. So over here we will get no solution. Over here we will get no solution. So here no solution is possible. That means this case itself is impossible. All right, so this is about how to convert one ITF to another. So does any one of you have any question or doubt in this one? Converting one ITF to another? All right, so we'll look for the few properties. So we'll start out with the first one. This first one is the important property. So the first set of property are these. That is, we say sine inverse x plus cos inverse x. This will be always pi by 2. Now that will be irrespective of the domain. Like not irrespective of the domain. Function won't be defined apart from the domain. But like whatever, as long as x is anything in the domain, that will be the case. Now, who will tell me that why sine inverse plus cos inverse is pi by 2? That's it. Take a triangle again, guys. Simple. Simple and easy. Let's take a triangle. We will assume that, let's say, sine inverse x is theta. So that means this angle is theta. So we'll get x equal to sine theta, and x is nothing but x by 1. So x by 1. That is the thing. We'll get it to be like this. Now, if that is the case, if let's say this angle is phi, what will be cos phi in this triangle? X. So what will be phi? Cos inverse x. And what will be theta plus phi in a right angle triangle? 90 degree. That is why we get this one. That is why we get cos inverse plus sine inverse is this. In a similar way, second, we can say that as long as it is in the domain, that means for any r, domain for tan and cot is r, all real numbers. This one will be pi by 2. And the last is cosecant inverse x plus secant inverse x. This in its domain will also be pi by 2. So in each and every one of them, we are using the same logic, nothing new. All right, so does any one of you have any doubt, any question till this point? All right, so guys, as of now, we'll stop over here. All right, and I request all of you to finish the function. 100 functional equation. We have not discussed even types of function, and one more worksheet I'll give you. Now, as soon as you finish it, if we have class tomorrow, then tomorrow we'll do ITF. Otherwise, any class we have after Tuesday, we'll do doubt discussion, and immediately after that, you'll have a test. So the day after the doubt discussion, you'll have a test on functions. And any class we get after Tuesday, that will be a doubt discussion. All right. Before that, we will just discuss ITF. That means if you have a class on Monday or Tuesday, we'll discuss ITF, or else doubt discussion, then test. All right, so finish the function properly, guys, because a lot of you learn through assignment. I have given you assignment in such a way that because not every question we are able to do in class. So whatever is left, whatever I wanted to do in class, that is then in assignment. All right, there are many more questions I can give you if you finish that assignment, but at least these are the ones I wanted you to finish. So that's all for now, guys. So we'll stop over here and see you guys later. So bye to all of you.